Hi guys! Welcome to our discussion about the using statistical techniques in analyzing the data. There are many instances in our life when you try to determine if some characteristics are related with each other. On a higher level, you also want to measure the degree of the relationship of association. You usually associate height and weight, budget and expenses, mental ability and academic performance, sibling order and attitude, civil status and managerial skills, and other aspects of life which may related with one another. The relationship between variables can be measured statistically by various correlation methods.
1. The scatter diagram. In figure 1, the points are plotted to show that the relationship between the values listed under column A, which are plotted on the x-axis, and the values listed under column B, which are plotted on the y-axis. Observe from this data that for every increase of 5 units of the items in column A, there is a corresponding increase of 3 units items listed in B. You will also observe that the points fall along straight line running from the lower left to upper right of the scatter diagram. This illustrates a perfect positive relationship when computed the coefficient of relationship is equal to 1. Plotting graphically the values of correlated variables means placing one variable on x-axis and the other on the y-axis. The scatter diagrams give you a picture of relationship between variables. Figure 2 is the opposite of figure 1. You will notice that for every increase of 5 units in A, there's a corresponding increase of 3 units on B. The points also fall along straight line, but this time, it is run from the upper left-hand part to the lower right of the scatter diagram. This is an example of a perfect negative relationship. When computed, the coefficient of correlation is equal to -1.
There are some situations in life wherein the relationship is not perfect. Figure 3 above is a graphical presentation of a scatter diagram wherein the points are not falling along a straight line, but the line is still apparent. These figures illustrate a very high positive correlation between the two sets of points. Figure 4. When the points are evenly distributed all over the scatter diagram, that will indicate that there is no relationship. So, let's proceed to types of correlation.
Simple correlation. This is a relationship between two variables. The relationship between an independent variable and a dependent variable is usually measured. Linear correlation. This means that a change in one variable is at a constant rate with respect to the change in the second variable. The correlation between the variable may either be showing direct or inverse relationship. Number 1. Direct. For every increase in one variable, there is a corresponding increase in the second variable. Number 2. Inverse. For every increase in one variable, there is a corresponding decrease in the second variable.
B. Curvilinear correlation. This means that a change in one variable is not at a fixed rate. It may be increasing or decreasing with respect to the change in the other variable.
Number 2. Multiple correlation. Multiple correlations involve more than two variables. The relationship between a dependent variable and two more variables is as usually measured.
A. Nonlinear correlation. The relationship in nonlinear correlation is similar to curvilinear correlation. However, in this correlation, more than two variables are involved.
Letter B. Joint correlation. This correlation between the dependent variable and two or more variables is changed with the addition of another independent variable.
Partial correlation. This is a relative measure of relationship between the dependent variable and a particular independent variable, without considering the effect of other independent variables under study. The coefficient of correlation. To obtain the quantitative value of the extent of the relationship between two sets of items, it is necessary to calculate the correlation coefficient. The values of the coefficient of correlation ranges between positive 1 to negative 1. 0 represents no relationship. Correlation coefficient between 1 and 1 represents various degrees of relationship between two variables. The Pearson product moment correlation coefficient, Pearson R. The Pearson product moment correlation coefficient is commonly called the Pearson R. This measure was first derived by a British statistician named Carl Pearson. It measures the linear relationship between two variables. Therefore, to be able to determine linearity, it is important that a scatter diagram be structured prior to computation of the Pearson R.
So, let's proceed to the computation of Pearson R. A. Computation of Pearson R. Pearson R can be computed based on row scores. The formula used is R equals n summation of xy minus summation of x times summation of y over the square root of n summation of x squared minus summation of x raised to the power of 2 times n times the summation of y squared minus the summation of y raised to the power of 2, where r coefficient of correlation, n is the number of samples, x is the first set of variables, and y is the second set of variables.
Example: the scores of 10 randomly selected senior high school students on the mathematical portion of the National Admission Test, or NAT, and mathematically ability part of a university admission test were recorded as follows. The scores of the mathematical portion of the NAT are listed under the column marked X, while the scores of the mathematical ability part of a university admission test are listed under the column marked Y. In the column marked X, 2 are the squares of each of the X scores, and in the column marked Y, 2 are the squares of each of the Y scores. The last column, marked XY, consists of the product of each X times Y. All the columns are summed up, and the values may now be entered in the given formula.
Second step, you sum up all the scores, and the summation of the first column is the summation of x equals 132. Second column, the summation of y is equals to 161. Third column, the summation of x squared is equals to 2110. The fourth column is the summation of y squared equals 3251. Last column is the summation of xy, which is equals to 2336. So after that, guys, you substitute all the summation of scores in the formula. So here is the substituted solution or the formula. R is equals 10 times 2336 minus 132 times 161 over the square root of 10 times 2110 minus 132 raised to the power of 2 times 10 times 3251 minus 161 raised to the power of 2. So, in the second step, you can follow the solution above. The sign of the coefficient of the correlation indicates the direction of the relationship between the two variables. A positive correlation coefficient means that individuals obtaining high scores in the first variable tend to obtain low scores in a second variable. So that's all, guys. Submitted by Avila Angel Rose, Bumanglag Alden Ver, Catalina Ricker Lance, Collis Ralph RJ, Eliado Chris Matthew, Hikaw Hazel Ann, Rasga Hazel May, Rivera Steven Rath. Submitted to Ma'am Myra Damasco, our practical research too. Thank you for watching!